another example of substitution. So here we're just looking for something, a function and its derivative. And so we're just going to plow recklessly forward and we're going to take a guess. I see that we've got sine and cosine. And sine is the sort of derivative of cosine, negative, but the negative will come out in the wash. We'll figure it out. Or cosine is also the derivative of sine, so which one to pick? I don't totally know. If you're looking at this and you can tell, hey, cosine is hidden inside of a third power, we should probably try cosine. That's very, very good intuition. I'm going to do it the wrong way. And the point of this example is to show you that sometimes if you try one U and it doesn't work out, just try a different one. All right, so first guess, U is equal to sine of t. Then du dt is equal to cosine of t, because the derivative is sine. And I'm going to, as I like to do, solve for dt. Du equals cosine of t dt gives us that du over cosine of t equals dt. And that's the substitution I'm going to use. So this little guy is this. Will become this. Yeah, let's lose a little squiggly here. And then u will be u. All right, so since I did that down there, we can just do the substitution directly above the arrow here. Okay, equals, well, sine of t becomes u. Okay, so u. And with my method, we just leave things that we aren't substituting with alone, and hopefully the algebra then within the integral works out. It's basically doing the algebra in the integral or before you put in the substitution into the integral. Two different methods. All right, so dt is du over cosine of t. And now I look at this and I see that there's no way that the cosine's going to reduce away and I'm going to be left with just an integral in terms of u. And so, nope, this didn't work. So we're going to try again. Doesn't mean all is lost. It just means sometimes we have to try again. So trying again, this time we'll say, okay, well, sine didn't work. Let's try cosine. Okay, once again, I'm going to use my little shortcut of saying the integral is equal to circle star. Our substitution is going to be cosine of t is u. Solving for our differentials or relating our differentials, du dt is derivative of cosine is negative sine of t. And solving for dt, you're going to end up with du is over negative sine of t equals dt. And if that was too quick for you, I encourage you to just pause and work through the algebra yourself, and you'll see it. Now we're ready to make our substitutions. So our integral becomes integral. What did we do? We left sine alone. So sine of t isn't involved, and cosine to the third power becomes u to the third power. And to relate our differentials, dt is substituted in for du over negative sine of t here. And if you need to put a multiplication dot in there, do so. It's fine. So right away, I see that that tidies up. I'm going to circle my minus sign so that I don't lose it. Okay, so that's really just a -1. And since you can pull negatives, or rather, since you can pull constants through an integral, we're going to go ahead and pop that -1 out in front. And then you're going to get, okay, I'm going to actually take the moment here to write this as u to the negative third power, because 1 over u to the third is equal to negative 1 over u to the third is equal to u to the -3. And that'll get me ready to integrate. Okay, so now we have something in terms of one variable that we can integrate. So the -1 just stays. And then u to the add 1, u to the -3 plus 1 is -2. And so multiply by the reciprocal, 1 over -2. So we're taking -1 times 1 over -2 there. It bothers me to, there we go. That makes it better. Plus c. Okay, negative times negative, or negative divided by negative, any way you look at it, is positive. So that just becomes 1/2. And we're going to go ahead and reverse our substitution while we're at it. So 1/2 cosine of t raised to the -2nd power plus c. And you could absolutely leave your answer like that. But I'm just going to write it like this because I don't really like negative exponents on cosine. And you can write it as 1 over 2 cosine to the 2nd power of t plus c. Either way would have been correct.